But how many B's do I have? So I end up with 100 D's. And each of those D's acts on 10 E's, which gives me 1,000 F's. That's the amplification. That's why God or Darwin made it like this. What do we have by the time we get to L? 1,000,000 molecules. It's advantageous to amplify it. And we'll see this in other examples over the course of the semester. One more time, we're going to start at the top because I don't want to leave anybody out of this. Enzymes are not consumed. They do their job. They're biological catalysts. They convert A to B, whatever it is. After they do it, they're not changed, modified, altered, used up. They can do it again. So one molecule of sucrase could split 100 molecules of sucrose. One molecule of sucrase could split 1,000,000 molecules of sucrose because the enzyme isn't consumed. So the one enzyme, cyclic AMP, converted 10 A's to 10 B's. Now every B converted 10 C's. Well, there are 10 B's. If every B converts 10 C's, that's 10 times 10 is 100. So the advantage of amplification is you amplify the product. The more steps there are, the more product you get. And if there's 12 to 15 steps in a typical pathway, like how many are we looking at? 1, 2, 3, 4, 5, 6? Imagine 12 to 15. We'd be over 1 trillion down here. All right. We'll gain closure by bringing this to life. So I want you to go back mentally, if possible. If not, use your notes. And I want you to look at the sympathetic division of the autonomic nervous system. All pathways in the autonomic nervous system have 2 efferent neurons, except one. What gland am I talking about? Adrenal medulla. And what does it release? Epinephrine. Dumps the epinephrine into the blood. When it dumps the epinephrine into the blood, the epinephrine is not a neurotransmitter, but it is a hormone. And this goes with the whole fight or flight thing, fear. And you get, again, you can look in your notes if you want to, but you get widespread vasoconstriction, things like that. But you get a massive increase in blood sugar. Because you're going to burn the sugar to make ATP because you need energy because you're fighting or you're running or whatever. If you look at the pancreas, for the people that weren't with me, remember all of my histology stuff is on your D2L site, this class, so use it as needed. But if you look at the pancreas, the islets of Langerhans, the alpha cells, the beta cells, blood sugar regulation. Blood sugar stays in a fairly narrow range, like the temperature in your home. Your furnace doesn't come on and heat your house to 90 degrees. Then your air conditioner comes on and cools it to 50. And then your furnace comes on and heats it to 88. And your air conditioner comes on and cools it to 42. It stays right about wherever you set it, 68, 70 degrees. Very, very narrow range. So this is the insulin glucagon, the glycogenolysis, the glycogenesis, islets of Langerhans, alpha cells, beta cells, all of that. Well, here's where your blood sugar goes when epinephrine comes in. Okay, it's going up. Okay? Massive, massive, massive increase in blood sugar. How does it happen? Instantaneously. And how does it go so high? cascade amplification. Okay, let's put our little mark. Crap, the attendance didn't go out today.